Welcome back, friends. We are starting with the next section, which is the Coulomb's law. Now we have an understanding that whenever there are two charges, they will either attract each other or repel each other. If there are like charges, they are going to repel, and if they are unlike charges, they are going to attract each other with a certain amount of force. Now Coulomb's law basically gives us the value of that force and of course the direction, right? So what I am doing is I am taking two charges QA and QB, which are respectively located at RA and RB. RA is the position vector of the QA and RB is the position vector of QB. And if I, just to begin with, I am just assuming that both these charges are positive. So this is a positive QA and this the second charge is positive QB, right? I need to find out the distance, the force which QA exerts on QB. Now you should understand that since they both are positive, they will repel. So in case I need to find force on B because of A, right? Force, how do you read this? This is force on B, so on QB due to the charge QA. It turns out that the force, the magnitude of the force is proportional to the two charges, and the force is inversely proportional to the square of the distance between the two charges. So assuming this, the distance to be r, the distance between the two charges to be r, then the force is inversely proportional to r square, right? This is very much like gravitation, what we did in class 11. The only difference is instead of the charges we had masses over there, right? So I can combine this. I can say the force on B due to A, magnitude wise, this is equal to some constant times the two charges upon the distance squared, right? This is the Coulomb's law. Okay, now since we are talking about force, we need to understand that force is a vector quantity and of course it will have some direction. Now as we are seeing from here and from our knowledge of vectors, we see that since both are positive charges, they are going to repel each other, and therefore the force on QB will be in a direction away from QA. Had they been unlike charges, then B would have been attracted towards A, in which case the force would have been in this direction from B to A. Now since they are like charges, the force is repulsive and therefore the force will be in a direction from A to B. The force on B due to A will be in a direction from A to B, right? So what we are going to do is, if I write this in a vector form, force on B because of A, this is going to be some constant. I'll talk about the constant also. Constant times QA QB upon r square, that's a magnitude, and the direction is A to B. A to B. This is the direction in which the force on B will be acting. So this is R A B, unit vector, and I can say that R cap AB is a unit vector pointing from QA to QB. Alright, this expression is what my Coulomb's law is. Okay, okay, I am writing the value of K. Now understand, K, constant for electrostatic, depends on the medium in which the two charges are, right? We will talk about K maybe all through the chapter and maybe in the next chapter also, but for now I'll explain what this is, but just for now understand that K this is small k by the way, lowercase k, this is equal to 1 upon 4 pi epsilon naught. This symbol epsilon and epsilon naught, this is called permittivity of free space. Free space means vacuum. So permittivity basically is an intrinsic property of a medium. How does a medium react with the electric field lines? How does the medium lets the electric field lines to pass through it? You will learn more about this, and I will give you more detail about permittivity of vacuum or permittivity of a specific substance, let's say when we talk about dielectrics further in this chapter. But just for now, just for a few video sessions, let's assume that this is some expression, right? I'm not asking you to cram it up, but just for now, till the time I explain in detail what permittivity is, just remember it like that. So if I rewrite this now, this comes out to be force on B because of A equals to 1 upon 4 pi epsilon naught QA QB upon R square, direction A to B unit vector. This is what the Coulomb's law is. Alright? Perfect. Any confusion, please do let me know, and I'll be happy to explain you further on this. Now, in this particular diagram, I have the position vectors also. If the charge QA is located at RA and charge QB is located at RB, the position vectors respectively, can I probably write the Coulomb's law in terms of the position vectors of the two charges? Let's see. Now, force on B, and using this directly, force on B because of A is 1 over 4 pi epsilon naught QA into QB upon R square. What is R? R is the distance between the two charges. So, can I say the distance between the two charges, the magnitude? Okay, so if this QA is located at point A, like this maybe, and this is located at B, can I say this is the square of AB? R is basically AB, and the direction is A to B, so I can say this is AB cap. Alright, perfect. So this comes out to be 1 upon 4 pi epsilon naught QA QB. Now this is a unit vector AB. Can I write the unit vector as the vector AB upon the magnitude of AB? And I already have the square of AB over here. So this turns out to be QA times QB multiplied by the vector AB upon 4 pi epsilon naught, the magnitude of AB squared cubed. Like this. Make sense to you? Okay. Okay, so this comes out to be force on A because of B equals to QA into QB upon 4 pi epsilon naught. Now look at the vector AB. I think we all of us remember what triangular law, what we did in class 11th was all about. So I can use triangular law of vector addition in this particular triangle. This is A to B vector. Can I say that OA plus AB gives me OB, in which case AB vector comes out to be OB minus OA, which is RB minus RA. Simple triangular law. So if I can substitute this expression from here over here, what do I get? This is RB minus RA vector divided by RB minus RA vector के magnitude का cube. This again is Coulomb's law in terms of the position vector of the two charges. Right? Please go through it. Any confusion, please let me know.